Good day, friends. Hope all of you are doing well. In the past few videos, we learned how to apply the idea of pseudoforce. Today, too, we'll apply the idea of pseudoforce to this problem. Block on accelerating inclined plane. This is a frictionless inclined plane having an angle of inclination theta. It's a block of mass m. If this inclined plane remains stationary, the block will slide down the inclined plane. Today, our objective is to find an expression of the horizontal acceleration of this inclined plane given the condition that the block remains stationary related to this inclined plane. Let the magnitude of the acceleration of this inclined plane be A, directed to the right. Now let's analyze the different forces acting on this block. The force of gravity, W, is equal to the mass of the block multiplied by the acceleration due to the Earth's gravity. The normal force is exerted on the block by the surface of the inclined plane, and let it be R. The pseudo force experienced by this block has magnitude F is equal to the mass of the block multiplied by the acceleration of this non-inertial frame of reference in the form of the inclined plane A. The block is stationary related to this inclined plane. So, it has no acceleration related to this inclined plane. The three forces acting on this block are coplanar. They act at the same point, and these three forces can be said to be at equilibrium since the block has no acceleration relative to this inclined plane. Hence, we can apply Lamy's theorem, which has already been stated in the past video. Now, before we apply Lamy's theorem, we should know the angle between the directions of each of the pairs of the forces. The angle between the direction of the pseudo force and the direction of the force of gravity is 90 degrees. If this angle is theta, then if we produce the line of action of the normal force, then the angle between the line of action of the normal force and the force of gravity is also theta. Thus, we can say that the angle between the direction of the normal force and the direction of the force of gravity is 180 degree minus theta. And then the angle between the direction of the pseudo force and the direction of the normal force is 90 degree plus theta. According to Lamy's theorem, we can write the normal force divided by the angle between the direction of the pseudo force and the direction of the force of gravity, 90 degree, so sine 90 degree is equal to the pseudo force divided by the sine of the angle between the direction of the normal force and the direction of the force of gravity 180 degree minus theta is equal to the force of gravity divided by sine of the angle between the direction of the pseudo force and the direction of the normal force 90 degree plus theta. From this equation, we eliminate the term that includes r. In the next line, we write in place of f, m a divided by sine theta is equal to, in place of w, we write mg divided by cos theta. Thus we get the expression of the acceleration of this inclined plane. A is equal to tangent of the angle of inclination multiplied by the acceleration due to the Earth's gravity. Thank you. In the next videos, we'll have more exciting problems. Thank you.